Hello there. This is the first time I'm making a video. This is my attempt to um, try to have what we had on campus for you to be able to benefit from maybe online. Um, I hope you're doing well, at least okay. Um, there have been lots of changes, but I think we can get through this and finish this semester together. So I'm going to do this video on solving trigonometric equations. This is something we started in class but we didn't finish. Now after this video you should be able to take the next test. So let me start by first getting rid of my video in the screen. We don't really need it. Takes a lot of space, and then start working on trig equations. So what we want to do is basically solve trigonometric equations, and we're going to start with very basic ones, and I think we did that in class, but I think you already know how to do them. So basic trigonometric equation is something like sine one of the trig functions, let's say for example sine function, equals to some number. So in order to get x by itself, you need to take sine inverse of both sides to get x by itself. So we end up with x equals to sine inverse of 1/2. And so we know that the answer to this right hand side is only one answer, but of course the answer to this equation is not only one solution, it's infinite number of solutions. So but this right hand side, with the help of the calculator, helps us actually. Let me get the calculator. So with the calculator we can easily find out what is the angle that has sine 1/2, and it's good if we are in degree mode. So when you put sine inverse of 1/2 in the calculator, you get 30 degrees. So you know it's 30 degrees, and we kind of knew that if you think about it in unit circle, sine 1/2 is about right here. So the question is, what angles have that sine 1/2? Well, it would be this angle, and there's another one, and that one is about right there. So now with the calculator, and also maybe you memorize it. Remember, you were supposed to memorize these numbers. So 30 degrees, or pi over 6, that's 30 degrees. And the other angle right here would be 180 minus 30, because this is 30 and this is 30. So that's 150 degrees, or in radian, 150 degrees is 5 pi over 6. So the two solutions are x equals to pi over 6 and x equals to 5 pi over 6. But we need to add 2k pi to both of these to get all the solutions. So we have to add 2k pi. For k, of course, is an integer, right? K is an integer. Okay, so these are all the solutions of this equation right here. There are infinite number of solutions, and these are all of them. So that's a very simple trigonometric equations. You could have actually cosine equal to something, maybe 1/2. You could have tangent equal to something, some number 3, or the other 3. Now these 3 really, that's all we need, because the other 3 are reciprocal. So if somebody want to solve the equation cosecant equals to something, let's say cosecant equals to 3, then instead we can just solve sine equals to 1/3. So we solve that instead. All right, or you can do it directly. All right, so well, let's move on and look at some examples. Here is an example, cosine 2x equals to negative square root of 3/2. So what we have to do, we have to take the cosine inverse of both sides. And what do we get if we do that? We get 2x equals to cosine inverse of negative square root of 3/2. Now, if you have no idea where that angle is, which I think you should, but suppose you don't, well, you can find cosine inverse of negative square root of 3/2, and that's 150 degrees. So 150 degrees, that's the only one that calculator gives us. Of course, we know on unit circle, negative square root of 3/2 is about negative maybe point something, 0.8 something, right here. So what angles have that cosine? Well, this one, which the calculator gave us, 150 degrees, which is 5 pi over 6. And then this one, which goes all the way around right there. Now, what's that one? Well, that one is 7 pi over 6. So the two solutions are 2x equals to 5 pi over 6 and 2x equals to 7 pi over 6. And then we have to add 2k pi. But we didn't want x, we didn't want 2x, we want x, so we divide by 2 and we find the final answer to be that. So these are all the solutions of this equation. Here's another one. This is a check. We could check this solution. If you substitute these numbers for x here and go through the simplifying, you eventually end up at the right hand side, which is negative square root 3/2. All right. So, and we know that if you think of this as the graph of the left side and the right side, then basically what we have here is the intersection. So these numbers that we found here are actually the intersection points of the graph on the left, which is this graph right here, and the graph on the right, which is basically that line. And those are the intersection points that we found. All right, here's another one. We have cosecant of something equals to square root of 2. We could take cosecant inverse of both sides. But instead, we can just write it as sine and use sine equals to, but of course we have to take the reciprocal of that, because sine is reciprocal of this side, then this has to be reciprocal of the right hand side. Now we take sine inverse of both sides again, and we have the answer. So if you take sine inverse of both sides, we get 1/3 x minus pi equals, again, what's sine inverse of 1 over square root of 2? Well, it's going to be pi over 4. So square root of 2 over 2 is about right here. So it would be this angle and this angle that have that sign. So it's pi over 4, and the other one is going to be 3 pi over 4. So, and that's what we have here. And then if you add 2k pi to both sides, to both of these, and then multiply, then move the pi to the other side and multiply by 3, that's what you're going to get. Because here if you move the pi to the other side, it would be pi plus pi over 4 plus 2k pi, or 2 pi k. Now that is 5 pi over 4. That is 5 pi over 4, right? And so it would be that 1/3. So right here we have 1/3 x is going to be 5 pi over 4 plus 2 pi k. 2 pi k. And then you multiply by 3, you get 15 pi over 4 plus 3 times 2k pi is 6 pi k, or 6k pi. That's right here. The same is true here. If you move the pi to the other side, that would be 7 pi over 4, and multiplied by 3 would be 21 pi over 4 plus 6 pi k. All right, and that's again is the graph of the intersection of these two, as you see here. And I need to delete this so you can see the intersections. All right, so let's move on. So here's another one that's cotangent. So we could take cotangent inverse of both sides, or we could just take convert it to tangent. Now if you convert it to tangent, then this would be 1 over 0. So that would be tangent of 3x equals to 1 over 0, which is infinity. We could do that. But we can also take cotangent inverse of both sides. What's cotangent inverse of 0? Well, cotangent inverse of 0 is going to be, well, we have a formula that works for. So what's the formula? We don't have cotangent inverse here, but we know that tangent inverse of, we know that tangent inverse plus cotangent inverse equals to pi over 2. So what is cotangent inverse of 0? Cotangent inverse of 0 would be 90. If I'm in degree mode, that would be, I'm in degree mode, so it would be 90 minus tangent inverse of 0, which is 90. So it's pi over 2, right? So it's pi over 2. Now in one period of cotangent, that's the only one that is equal to, that's the only angle whose cotangent is 0. So we're going to write 3x equals to pi over 2 plus k pi, right? Now, since this is 3x, we have to multiply by 1/3, and that's how we get that. That's the answer. Now, secant squared equals to 4. So again, we can't deal with secant squared, we can deal with secant. So we could take square root of both sides. So, or we can write it as cosine squared equals to 4. So 1/4, not 4, my fault. Well, I'm going to just put 1/4 here. So cosine is going to be either 1/2, or cosine is going to be negative 1/2. So from cosine 1/2, see, let's put 2. So cosine 1/2 would be that angle right there. And then again is this angle, that cosine is 1/2. So it's this one, and all the way around this one. What are those two angles? Well, again, if you don't remember, you can always use the calculator and do cosine inverse of 1/2, and you get 60 degrees. So that's pi over 3. That first one is pi over 3, and this big one is going to be 5 pi over 3. So now that's for only this equation, which is given over here, pi over 3 and 5 pi over. But what about this one? Well, negative 1/2 is over here, so this angle and this angle, so this one, and all the way around this one has that cosine, negative 1/2. So what's that angle? But again, if you don't know, calculator can give you 1, and that's one answer is good enough for us. Negative 0.5, and that's 120 degrees. 120 degrees is 120 degrees, 2 pi over 3. So that would be 2 pi over 3, and this one would be 4 pi over 3. 4 pi over 3. So that's how we get these. So there are 4 equations that give us all the answers for this problem. Tangent x over 2 equals to negative 3. Again, we can do this using tangent directly. We can use tangent, or so let's do tangent. So x over 2 is going to equal to tangent inverse of negative 3. Now what is tangent inverse of negative 3? Again, tangent inverse of negative 3. Well, it's like 71, negative 71 point something. But so it's going to be right about somewhere right here. That's where the tangent is, negative 3. But that's not in one period of tangent. We can use that. We can also use this one. This has the same tangent because they have the same sine and cosines are positive and negative, but the values are the same, so the tangents will be the same. So we can use this one, or we can use that one and add k pi to it. So x over 2 is going to equal to whatever that angle is. We could just write it as that if we don't want to write it as an angle. So we're going to write it as tangent inverse of negative 3. So we can write it as tangent inverse of negative 3. So let me erase these. So I'm just going to write it like tangent inverse of negative 3. So that's an angle. We don't find it. We just leave it like that. Plus k pi. Now multiply by 2, then you get that. That's the answer. Remember, arctangent is the same as tangent inverse. All right, now here we have sine 2x and sine 2x. We can take sine inverse of both sides, and we get 2x equals to sine inverse of 0.87, but sine inverse of 0.87 is not an angle that we recognize. We don't memorize that, so we want to leave it to people who want to use this to decide how many decimal places they want to use. So we're going to just leave it as sine inverse of 0.87 plus 2k pi, and then divide by 2. Now, that's of course is only one of them. So it's a good thing to actually find out what that angle is. So let's see. Sine inverse of 0.87 is about 60 something degrees. So it would be over here. My pen is not working. There you go. So it's going to be over here somewhere, and so that's the angle. But we know there's another one that has the same sign and would be on this side right here. They have the same sign. So this one is sine inverse 0.87, or arc sine 0.87. Now what's the other one right here? Well, we know these two angles are the same, so that bigger angle would be pi minus this, and that's what you get here, pi minus. So we got two angles. We got that one and the pi minus, and then divide by 2 and we get the solution. Okay, now and I have here, that's in radian, 1.0 something, that's in radian. And this is the picture geometrically. We are basically finding the intersections of the two functions. All right, now this one is something we can't directly do. We have to change the form of it. To change the form, we can think of it as 3x squared equals to x squared. It's like a polynomial. So you can think of it as 3 u to the third equals to u to the second. How would you do that? Well, we move the u to the second to the left side and then factor u to the second, like that. Now we want to do the same thing, except we assume that we don't have to just write u, we can just think of it as sine. So you see that expression is exactly like we have here, except sine is u. All right, now this is the product of two things equal to 0. Either sine squared is 0 or that is 0, and in either case we're going to have two answers. So if you have sine squared equals to 0, then sine equals to 0, and we can get two answers from there. So either sine squared equals to 0 means sine is 0, or 3 sine x minus 1 equals to 0, that means sine equals to 1/3. So we got two equations. Either sine is 0, when is sine is 0? Here and here, which is basically n pi, k pi, 1 pi, 2 pi, 3 pi, negative 1 pi. So that's what it is. Or sine x 1/3, 1/3 is about here. Well, we don't know what that number is, but we can find it with a calculator or leave it as just sine inverse of 1/3. So it would be, that would be sine inverse of 1/3, but this bigger one is pi minus sine inverse of 1/3, which is this one right here, right? So x equals to n k pi is one solution. X equals to sine inverse of 1/3, which is this angle right here, plus 2k pi is one solution. And then another solution is this angle, which is pi minus that, minus sine inverse of 1/3, plus 2k pi. So these are the solutions. Now, we want to find solutions from 0 to 2 pi. Then we can let k be 0 right? If k is 0, we get 4 answers. This one gives you 0. This one gives you whatever that is, which is 0.3339. And this one gives you pi minus that. And this one gives you pi if k equals to 0. So we get that. If k is 0, we get 0, that number, this number. That's 1, 2. And then if k equals to 1, we don't get any out of those, or we get 1 out of here. If k equals to 1, we get pi. So we have to add that too, because pi is within 0 to 2 pi. But if you let k be 1 here, you go past 2 pi, or here, or here. These two. And this one gives you an answer for k equal to 0 and k equals to 1. And these give you answer for k equal to 0. So 2 from here and 2 from here. All right. We get the picture again, geometric picture of that. Let me erase this stuff so you can actually see that too. So what we just did, we found all the intersections between that green and the red graphs. All right, so solve the following equations. Again, this is not something we can do directly because we don't have one of these functions by itself. So we have to convert these to one of those 6 ratios, 6 functions. So to do that, we use the connection between tangent and secant. So instead of secant squared, we can write 1 plus tangent squared, and then move everything to one side, and looks like a quadratic equation. U squared minus u minus 2, if u is tangent. And then factor it, find u. So either u is -1 or u is 2. So that means either tangent is -1 or tangent is 2. Now when is tangent -1? Calculator gives you an answer for that, right? So tangent equals to -1 or tangent equals to 2. And we can easily use a calculator to do that. Now, when is tangent -1? Well, you should know, but again, calculator is your best friend here. So we're still in degree mode. So we go tangent inverse of -1 is 45 degrees, and tangent inverse of 2 is some 63 something. So it's not an exact answer, so we just leave it like tangent, arctangent of 2, or tangent inverse of 2, plus k pi. So negative pi over 4 plus k pi, and arctangent of 2 plus k pi. All right. Now this one, we have to convert cosine 2x to cosine x somehow, and we get a connection between them, and that is that formula from identities, that cosine 2x is 2 cosine squared x minus 1. So instead of cosine 2x, we can write 2 cosine squared minus 1, and then just like previous problem, we're going to get a polynomial quadratic and solve it. So either u is 1 or u is 1/2. Either u is 1, and that is either cosine is 1/2 or cosine is 1. And again, you should know that cosine is 1/2. If the angle is here, or here. So it's this one or this one. And cosine is 1 if the angle is here. That's it. So 0 plus 2 pi k, and then that's from here, from this equation, we get only 1. And then from here, from this equation, we get 2. And all of those are solutions. If you want from 0 to 2 pi, you have to just pick k equal to 0, and you can pick the ones that are in 0 to 2 pi. All right. And here's another one. Cosine 3x equals to cosine 5x. Well, we have identities that relate those. If you look at your identity, you see the difference of the difference to product and product to sum and sum to product. All of those formulas can help us do this. So if you move the cosine 3x to the right hand side, we get cosine 5x minus cosine 3x, which is, by the identities, difference to product, it would be that. So it would be 2 sine, negative 2 sine of this one plus this one, and then sine of this one minus this one. All right, and when we get it, it's just very easy. So basically, when you move this to this side, one side becomes 0, right? When you move this to this side becomes 0. So basically, we have this equal to 0, right? That's what we have. And either sine is 0 or sine 4x is 0. And from sine is 0, of course, we just said that. So now this one, 4x equals to 0. 4x equals to pi k, so x is pi over 4k. But since k can be an integer, that means when k is a factor of 4, then you get these two. So this answer is kind of built into that one too. So you can just say the answer is this, and you get these out of it too. But it's not wrong if you write both. Right? You see, when k is 4 or when k is 8, basically you get these answers too. And answers which lie in 0 to 2 pi would be, well, when k is 0, when k is 1, when k is 2, when k is 3, you all get answers from here, right? So here you only get answers when k is 0 and 1. But over here, k can, so when k is 0, we get 0 from here, and we get 0 from here, which is the same. If k is 1, we get pi from here, and we get pi over 4 from there. And when k is 2, we get pi over 2 from here, and we get 2 pi from here, but we don't want that, so we just use that. So it would be pi over 2, and then when k equals to 3, we get 3 pi over 4, this one. When k equals to 4, we get pi. Notice we don't get anything from here after k equals to 1. And so forth. 5 gives you this, and 6 gives you this, and 7 gives you that, all from here. And 8 is going to give you 2 pi, and that's not going to work. All right, solve the following equations and list the solution which lie in the interval. Again, sine 2x, we can relate it to cosine. This sine 2x is 2 sine cosine. And then if you write that and move the cosine to the left side, then we can factor it, right? So now, if you move this to the other side, we get that. Now that we can factor the cosine out of them. So either cosine is 0 or 2 sine x square root of 3 minus square root of 3 equals to 0. So we get two answers. either cosine equals to 0 or sine x equals to square root of 3 over 2. Now cosine equals to 0 gives us that, pi over 2 and 3 pi over 2, and so that's what we get. And then cosine equals to sine equals to square root of 3 over 2 gives us this angle here and this angle. And that angle, of course, is pi over 3, and the other one is 2 pi over 3. All of those are answers, but of course we only want the ones from 0 to 2 pi. So we need to let k be 0, and k, that's it, if k is 0, because if k is 1, then it goes past 2 pi. So that's it. We get 4 answers. 1, 2, 3, 4. When k equals to 0. And again, I always cover this with writing. And that is the geometric picture of what's going on. All right. So again, here is one which is directly related to the sum and difference, or one of those formulas on your identity sheet. So if you think of this, that would be the sum of two angles. So sine of A plus B is sine of A cosine B cosine A sine B, and that's a structure that on the left we see. So the left side can be written just like, instead of left side, the whole thing here, instead of all that, we could just write sine x plus x over 2. And, well, x plus x over 2 is 3x over 2. That has to equal to 1. And that's it. So all we have to do is just take sine inverse of both sides here. So 3/2 x equals to, what angle has sine 1? Pi over 2 plus 2k pi. And that's the only one. So multiply by 2/3 to get x. So we get pi over 3 plus 4 pi over 3k. Those are all the solutions. But we want the ones from 0 to 2 pi. Let k be 0, let k be 1, and we get 2 answers. And the picture, we don't have the picture for this, but that's okay. All right, now the last one we want to talk about is the one that is actually tricky. If you have like some number times cosine plus some other number times sine equals to some number, this is called a linear combination of sine and cosine together. This shows up in application problems a lot. So if you have something like that, we don't know how to solve it because we don't have one function by itself on one side. So how do we solve these equations? Well, I'm going to let you think about this for a second. Okay, so how do we do these? Well, we're going to look at that right there in order to be able to do it. So the way it is done is by converting a structure like this to something simple so we can actually solve for sine. Now, how do we convert this structure to just something like this? Well, we know that sine of x plus phi, or a plus b, doesn't matter. We have a formula for it from our identity chart, right? So basically the right hand side is this. That's what the right hand side. So this is the right hand side. That means we want that to be equal to this. So basically we're going to put it here. See, I color coded it, so you see. Now notice that this one has sine right here, sine x, and this one has sine x. This one has cosine x, and this one has cosine x. And then the rest of the stuff, the red stuff here together, basically is d, and the blue stuff is e. So if you set d equal to a sine phi, which is a times that thing right here, and let e be a cosine phi, then this structure equals to this structure, right? So that's what we do. Now, if d equals to a sine phi and e equals to a cosine phi, right? Then if you square them, square both sides, then d squared equals to a squared sine squared phi, and e squared equals to a squared cosine squared phi. And if you divide these two equations, divide this by this, divide the right side by right side, then the a squareds go away, sine squared over cosine squared, which is tangent squared, equals to d squared over e squared. So d over e is tangent phi. So that, plus the fact that we know that since if you square this and square this and add them, we end up with what? We end up with a squared. So that means d squared plus e squared is a squared. So a is given by this formula, and phi is given by this formula. If we do that, then we're going to convert, we can convert something like this to something like this and solve it. So let's do an example. So here is our d is 1 here, and our e is negative square root of 3. So that's what we want to do. So you see the formulas from the previous page. A is that, and remember tangent phi has to be d over e, and the calculator of course gives us only one answer, but we might be in another quadrant, so we have to have that too. If we are in quadrant 2 or 4, right, now calculator only looks over here for tangent inverse, right, 1 and 4, but if you're in 2 and 3, then the calculator doesn't give you the correct answer. Calculator gives you the wrong answer. So I'm over here, I'm looking for this angle, and the calculator gives me that one. So what I'll have to do, I have to add pi to it to correct it. Only if you're in here, 2 and 3. If you're in 1 and 4, then this tangent inverse gives you the correct answer. Okay, so let's see how we can solve this. So we know what a is. A is going to be square root of this squared plus that squared, so a is 2. So if you want to write this as, write this whole thing as 2 sine something, so if I want to write it as a sine x plus phi, doesn't matter, omega t or x is the same thing, then over here I need a, so a is 2, so that's 2 so far, So this thing so far is just 2 sine. So all we need is that x is going to be x plus some phi. But what is phi? Well, let's see. We know d is 1 and e is negative square root of 3. So we know sine has to be, sine of phi has to be positive. How do we know that? Because remember, sine is d over a and cosine is e over a. So if a is 2 and d is 1, that means sine is 1 over 2, so it's positive. And cosine is going to be e over 2, so that's negative. Cosine is negative and sine is positive. When is cosine? Where is cosine? In what quadrant cosine is negative and sine is positive? Over here, second quadrant. So we are in second quadrant. That means we have to find tangent inverse and add pi to it to get the correct phi. So phi is going to be pi plus tangent inverse of d over e, which is that right there. So we get 5 pi over 6. So if I put 5 pi over 6 here, see, then, so instead of all that equals to 2, we could just put this equals to 2, right? And solve that. And everybody knows how to solve that. That's an easy one to solve. All right? And because you just divide by 2 and then take sine inverse of both sides and you have the answer. All right, so I am going to go now to the Newton-Alta side and do some of these problems quickly. So there you go. These should be really easy to do. We did much harder problems. These should be really easy to do. So solve for theta if that equals to this and theta is between 0 and 2 pi. Okay, so it's really easy, right? All we have to do is isolate sine theta and we go from there. So let's get the answer. How do we know it's the answer? Well, let's see. Let's make sure we know how to do this. So sine here is going to equal to negative 6 square root of 3 divided by negative 12. So that's just the square root of 3 over 2, right? So sine is square root of 3 over 2. When is sine square root of 3 over 2? Just about right there. Well, right here. And we know that's pi over 3, and over here, which is 2 pi over 3. Now, of course, we only want two answers here because it is only between 0 and 2 pi. So the answer, it's only two answers, but of course we can find all of them. Okay? Let's do one problem from here. These are all easy problems, right? So again, isolate sine, we get sine equals to 0. When is sine equal to 0? Well, only when when theta is 0 or pi, right? That makes sense? All right. So that's an easy one to solve. So all of these are just the simple basic ones. So I'm just going to go to the next one with single trig functions. Let's see. All right, so 3 cotangent equals to what? Well, let's see. We have how many answers? 315. Okay, there you go. So let's have some space here so we can work on. So cotangent has to equal to negative 11 plus 8 divided by 3. So cotangent is, that's a negative 1, right? So when is cotangent negative 1? Well, Remember I showed you that there is a cotangent axis too right here. You could look at that. So -1 would be here. So the angle that's cotangent is -1 has to be there. Now, suppose you don't know this and you want to use the calculator. Again, calculator doesn't have cotangent inverse. So what do? We use degree mode. The degree, yes. So we're going to do 90 minus tangent inverse of -1, which is 135, right? That's 135. So this angle is 135. Was it 135 in radian? Well, we don't want it in radian, we want it in degree. So got the answer. And we want from 0 to 360. We don't want all of them, but if you want all of them, you have to add k pi to it. So 135, and then we have to go around and get another one that has that, because the period of cotangent is pi, but we want to go over 180 degrees, so we want to go 360. So there's another one that is 315, which is, let me show you where it is quickly. So that would be, so from 0 to 180 there is only one, and that's the one right here. But if you want to pass this and go to 360, there's another one, which is that one. So you have to add pi to it, and add 180 to 135. That's what you get. You get 310, 315. All right. Solve the following equation for theta. Again, cotangent, you isolate it. You get 1 plus 5, 6 divided by that, right? And again, from 0 to 2 pi, what is the answer? Well, let's see. Let's do this one together as well. So we got cotangent equals to 1 plus 5 divided by 6 square root of 3, which is 1 over square root of 3, or just square root of 3 over 3. So again, let's get the calculator, and so we do, this time we're going to do 90. Again, we are in degree because we want to know what it is in degree. And we do tangent inverse of 1 divided by square root of 3. So 60 degrees. So now if you think of, again, that axis, 1 over square root of 3 is about right somewhere here. So this distance here is 1 over square root of 3. So that's the angle. That's pi over 3. Now, there is of course another one right here, which is pi over 3 plus pi. And so there are two answers, pi over 3 and pi over 3 plus pi, which is 4 pi over 3. All right. And same kind of stuff, you can use a calculator to do this. It's a very simple one. These are just using calculators, approximating. And so secant, we isolate secant, and then so we can isolate secant here. So secant equals to -15 plus 3 divided by -6. So secant is going to be -12 over -6. That's 2. So secant is 2. So cosine is 1/2. So from 0 to 360, when is cosine 1/2 here and here. And again, you can use the calculator to get this. If you don't remember, again, cosine inverse of 1/2 is going to be 60. So that's 60 degrees, and let me see. Yeah, I did it right. -12 is 2, so cosine is 1/2. So cosine is 1/2. So 60, and what is the other one? Was 360 minus 6, 300. So it looks like there is only one of the answers in this list. Oh no, the rest of them are down here. I didn't see the rest of them. So 60 and 300. Those are the two. All right. All right, so I don't see anything that is difficult over here. These are tangents and just single trig functions. What about this one here? This is in quadratic. I did a few of these for you. Let's do one more of these. So here, well, we have a quadratic actually form. You just move the 3 to this side and we solve it as a quadratic. So we can do this together quickly. So we're gonna think of this as 4, just 4u squared minus 4u minus 3 equals to 0. And so u is going to equal to what? Then we solve this. U is going to be negative b plus and minus the square root of b squared minus 4ac over 2a. So that's 16 plus what about that is 16 minus 16 times 48. 16 plus 48 is 64, so that's 8. So 4 plus and minus 8 over 8. So either u is 4 minus 4 plus is 12 over 8, or u is negative 4 over 8, which is negative 1/2. Now 12 over 8 is bigger than 1, so that's out, because u, remember, is cosine, so that can't be. So the only one that makes sense is when cosine of beta is negative 1/2. Can't be that, right? It's greater than 1. So when is cosine negative 1/2? Well, negative 1/2 is here, so it's this angle. Now we know cosine of 60 is 1/2, so that should be that one is related to 60, and that one. Now what are those two? Well, you should know those two. Those are 2 pi over 3 and 4 pi over 3. All right. So, see, those are the numbers that we found. This one doesn't work because it's greater than 1, and this one, the only one that works, right? Instead of cosine, we just use u, and instead of factoring it, I just use quadratic formula. All right, so the same kind of stuff, either, again, tangent is u now. You get 2 equations for tangent, and you can solve it. And that's what you're going to end up getting. So let's see if there is anything interesting here. Well, this one would be just sine squared. You isolate sine squared and you do it, right? Not very difficult to do. And this one again, isolate cosine squared. I'll let you do that. And here again is quadratic form. You see, like 5u squared minus 8u plus 2. I think you can do that. The only difference here is that angles are not nice, so you get decimal answers. Let's do this one now that we're added. Why not? There you go. Let's do this one. So we got 5u squared minus 8u plus 2 equals to 0. So u here is 8 plus and minus 64 minus 4 times 5 times 2. Now 44, so this is not a nice, so u is not very nice, so u is going to be 8 plus or minus square root of 24 over 10. So your u is like two numbers that, let's see what they are. Let's approximate them with the calculator. So u is either 8 plus square root of 24 divided by 10. So u is 1.289. Let's see. And or is 8 minus square root of 24 and then divided by 10, which is 0.3 something. 0.3101. Okay, so u of course is cosine, so we are looking for cosine, and this is in radian. Yes, so we are going to have to, first we're going to do it in degrees just to have an idea of where these things are. So cosine inverse of 1.2899, that can't be, that's greater than 1, so we have to use only that one. What am I doing? Cosine inverse of 0.3101 is going to be 71 point something degrees, so we know where it is. So let's change to radian now and do the same thing. Alright, so it's 1.26. So the only equation that's going to work is when cosine of theta is 0.3101. And the answer to this is 1.26. Now 1.26 is 70 something degrees over here. But that's not the only one that has that cosine. Also have this angle right here. So if this is 1.26, then what is this one? Well, that would be 2 pi minus that. And what is 2 pi minus that? Let's see. What is 2 pi minus 1.26? Is like 5.023 something. It's that one right there. So we got both of those in terms of radian, right? So it's this one and that one. That's how we get it. If the angles are not nice, we have to use decimal places. All right, the same thing here. So I'm going to let you do the rest of this, and I'm going to go over here, the one that require identities, do a few of those. We did a bunch of them, but just to make sure. All right, so solve the following equation for beta. Now, so we have to relate these. If you relate them, 1 minus cosine squared looks like a sine squared, right? And that would be sine squared beta. And then over sine, you can cancel one of these, because sine of negative something, you can bring the negative out and write it as negative sine to the third, and that would be sine squared. So basically you have 1 over sine equals to negative 2. 1 over negative sine equals to 1 over 2. So I'm going to show you here the work. So 1 minus cosine squared is sine squared, so we can write it as sine squared. Looks like not much work is shown, so I'm going to do it here. So instead of that, we're going to write sine squared beta, and so it would be sine squared beta over negative sine to the third of beta. Remember, sine of negative beta is the same as negative sine beta, and equals to negative 2. So this cancels 2 of these, so 1 over negative sine beta equals to negative 2, and so negative sine beta times, if you cross multiply, that would be basically, well, let's put negative 2. So positive 2 sine beta equals to 1. So sine beta equals to 1/2. Right? And, well, what angle has sine 1/2? Well, this angle, and if you're from 0 to 2 pi, and that one. So it would be pi over 6 and 5 pi over 6, right? And those are the solutions. So identities, you have to just see how you can, the point is you have to have one of these. Now this you don't need identity, because you can just solve for 3x, right? And we have done one of these already. So yeah, that's just something we did already. And I think you're in good shape for solving trig equations. And this one, secant equals to cosecant. So secant is 1 over sine, 1 over cosine, and this is 1 over sine. Well, you have to write a connection between them, secant and cosecant. So let me see if we have something to work with. Yeah, so if you think of function and cofunction, now when a function equals to a cofunction of another angle, then these two angles, this one and this one, have to be complementary. That means they add up to 90 degrees because of this. So if you set those equal summum, and summum equal to pi over 2, then you can solve for theta and you get it. All right, so that's the trick we use. The same is here. Sine and cosine, that's a function and cofunction. They're only equal if the angles add up to what? 90 degrees. And if you add them and set them equal to 90 degrees, you're going to get that, right? See, set them equal to, sum equals to 90 degrees. All right, so these are I think all same kind of stuff. All right, so next video, what I'm going to do, I'm going to talk about the next test, the next set of concepts, which is basically two of main one, law of sines and law of cosines. All right, so I'm gonna see you in the next video. So this one I'm gonna mark as whatever chapter this is. I have to look it up and see what chapter, but it's going to be under videos in Blackboard in course content. Okay, so take care. I'll see you in the next video.